everybody. I'm going to go over some trigonometric proofs with you today, and hopefully you can use this video to help you as you're working through your own problems. A lot of the tricks and tips that I wrote down in class last time are actually right here on this handout as well, so we can look at them and read through them. I'm not going to read them to you. Some of the things I've marked here: sines and cosines, we talked about that as a goal, Pythagorean identities as a good goal, algebraic type things you can do. Most important thing to remember, one side is where you're working. Work one side to match the other and focus on changing the more complicated side into something more simple. So, something like sine times secant, if I use my strategy of all sines and cosines, the change I would make is I would replace secant with 1 over cosine. Hopefully, after doing that, you look at that and think, okay, I can sort of see where this is coming, and you should always be looking at your purple sheet as you're practicing to kind of help you start recognizing, like, maybe I'm getting close to something. A sine times 1 over cosine would make a sine over cosine. And sine over cosine is tangent. But we want to finish this proof by explicitly saying sine over cosine can get replaced with tangent. And so every proof should end with an undeniably true statement. Tangent equals tangent. Sine equals sine. Cosine squared equals cosine squared. I should be able to read your proof kind of down one side and see how one side changes to become the other. And some students, if you just want to like carry that down, you don't necessarily have to write it on every line. The more organized you are, though, the more successful you tend to be doing these. So you might want to stop and try number 2 and number 3 because they're both very similar. They use both the reciprocal identities and or the quotient identities to make the proof happen. Okay, if you've restarted, you can see my attack on number 2. Once again, going with my sines and cosines approach. I'm using some fraction arithmetic strategies here. When I have fraction multiplication, when I have one fraction times another, you can just multiply across and then reduce. Or you can cross reduce or cross cancel, it's been called ahead of time. A 2 and a 2 both have factors of 2, so a 2 into 2 goes one time, so 2 divided by 2 and this divided by 2. So this became 1 over 3 times 1 over 1, and that's another way to get to 1/3. When the numbers are little, it doesn't seem to make a big difference. But sometimes when the numbers are bigger, like if I had 10 over 50 times 500 over 80, it's kind of nice to be able to like say, okay, 10 goes into 10 one time, 10 goes into 8 times, 50 goes into 50 one time, 50 goes into 500 10 times, and then I can multiply and then reduce, versus doing the multiplication, maybe making a mistake in the multiplication, and then reducing. So some of these fraction tricks are what you're going to see as tools that we use to help do our proofs and our simplifying. So in this case, we have sine over 1 times 1 over 1. So that's a sine times 1. And I think we can see pretty quickly, oh, yep, that's true. Sine times 1 is a sine. Sine equals sine. Check. Check. I have a cosine. I have a 1 over sine. I'm using my same strategy. Tangent, I would write as sine over cosine. That's my quotient identity for tangent. And whether you want to reduce ahead of time or multiply, you're going to get a cosine times a sine in the numerator, and a sine times a cosine in the denominator, and everybody divides out. When they divide out, they leave ones. 1 times 1, 1 times 1, 1 equals 1. I'm going to pause right now. Okay, I'm back. There was just a weird announcement. Okay, so problem like number 4, we've got kind of more things going on. When I start seeing additions and subtractions, I then start thinking potentially Pythagorean identities. So when I see a sine squared plus a cosine squared, I absolutely always replace that with a 1. So tangent times cotangent plus 1. Now I can kind of see it would be really awesome if I could kind of finish this with another 1 here, and I can do it a couple different ways. What I'm going to do is I'm going to leave tangent, and I'm going to change cotangent into 1 over tangent. That's a really easy way to see the product of those two pieces, since they're reciprocals, is also 1. 1 plus 1 equals 2, 2 equals 2, and that's a check. If it doesn't feel like we're doing much differently from when we were simplifying, you're 100% right. We are just sort of simplifying one side, but we have a goal on the other to get to. I'm going to write out some of these other problems for you to see. Okay. And you should be able to go ahead and look at them step by step by step in the note handout that I'm going to post. And then with looking at these, hopefully you'll be able to do at least part of the problems on worksheet 3. I feel like we should do at least a couple more though. So let's take a look at, I think number 8 is a good one to look at. On number 8, we've got 2 sides, and one is a little bit more complicated than the other. Okay. So 8 is, but you could definitely see where you can use identities to work with both sides. In this case, I tend to think about something like the left side of this, a big product, to be more complicated. And if I attack the left side of this, and I think maybe I'll do sines and cosines, because in my head, I'm kind of thinking about this, 1 minus cosine squared. I'm kind of thinking, I know that's the same as sine squared. I'm not going to write it down, but I'm thinking that in my head because that might help me sort of focus on the goal, because if I can get sine squared, I can then get 1 minus cosine squared on the very next step. So it's kind of like giving myself an intermediate goal where I didn't change what was on the right, but I thought about something else I could do with it. That 1 minus cosine could be cosine squared could be sine squared. So let's see. If I kind of work my way back up, and I even look at the original problem, I'm like, well, that sine squared is there. Wouldn't it be nice if those guys canceled? They do cancel because secant is 1 over cosine, and those cosines would divide out to be 1. So the only thing left on this side would be sine squared, which is exactly what I have here, and sine squared is equal to 1 minus cosine squared. So sometimes you might be thinking about this side and other things other ways to write this side, even though you don't change it. And that might help you to think, okay, if I can get the other side to that point, I know how to finish this. I kind of think something similar on number 9, because I look at this side and I think, I know cosecant is 1 over sine. So maybe if I can figure out how to get cosecant x to 1 over sine, then I can finish this and only change one side. A fraction, it's always easier if I can rewrite that fraction as something simpler. A simpler fraction would not have any additions or subtractions or multiplications or divisions inside the fraction. It would just have a single numerator term and a single denominator term. So when I see 1 minus cosine squared, I think, well, sine squared is a good result. And then that means, just like x over x squared would reduce down to 1 over x, sine over sine squared reduces down to 1 over sine. And 1 over sine is equivalent to cosecant. Cosecant equals cosecant. Okay, so this has given you some ideas, some things you can go back and look at slowly and look at how the steps on how they developed. I'm going to write out the rest of these proofs up to number 10, and hopefully you can then fill out your notes up to number 10 and see which problems you might be able to do on worksheet 3. Thanks, and have a good rest of your day.